A killer whale off the coast of South Africa has been caught on camera hunting and killing a great white shark. We thought we knew orcas. For decades, they've captivated us. Black and white sea wolves gliding through oceans with grace and power. Tragic story makes you wonder what we're doing, confining these majestic and clearly very dangerous creatures. But here's the twist. We were only seeing part of the story because they just discovered a new type of orca, and it's unlike anything ever seen. This isn't just about new behavior or an interesting quirk. This is truly one of the most amazing encounters any of us have witnessed in the wild. It's a revelation that's forcing scientists to redraw the lines between species. What if the ocean's most iconic predator has been hiding an evolutionary secret right in front of us? Let's dive in, because the truth about these orcas is wilder than fiction. The orca species that shouldn't have existed for the longest time. The ocean's apex predator wore a mask of simplicity, the orca. Black and white, sleek, intelligent, was catalogued under a single name. Orcanus orca *. It didn't matter where they were seen, from the freezing Arctic to the tropical South Pacific. They were considered one species, one identity. Their global consistency became part of the myth, a super predator capable of adapting to any ocean and hunting anything in it. But somewhere along the Pacific coastlines, from Alaska to California, that categorization began to crack. The shift wasn't sudden. It wasn't one dramatic moment of discovery. Instead, it came from a slow accumulation of questions that science could no longer shrug off. Why were some orcas silent hunters, while others filled the sea with their clicks and calls? Why did certain pods stick to fish even when starving, while others hunted seals and whales with terrifying precision? And most intriguingly, why had there never been a single case of interbreeding between two groups, even when their territories overlapped for centuries? By 2024, the weight of decades of observation, data, and DNA analysis tipped the scales. Leading marine biologists began pushing for a radical rethinking, that the orcas we've been calling transients weren't just a quirky offshoot or regional variation. They were, in all likelihood, a completely different species. Now that the blindfold's off, the next question hits even harder. What exactly makes these orcas so different that they may no longer belong under the same name? What have they been doing all this time to carve out a genetic and behavioral identity of their own, not a different pod, but a different specie? Imagine watching a group of orcas gliding through the sea. At a glance, nothing feels off. Their movement is familiar, their coloration identical. If you didn't know better, you'd assume you were watching the same kind of animal that appears in every nature documentary. But spend time with them. Follow their patterns. Study their prey. Listen for their voices. And something begins to feel off, not subtly different, but fundamentally alien. These orcas are known as transients, though that label now feels misleading. It implies they're just wanderers, social outliers, or nomadic fishers. But that couldn't be further from the truth. These orcas aren't simply doing things differently. They're wired differently, physically, behaviorally, ecologically. Let's start with how they hunt. While other orcas, particularly residents, rely on echolocation to find fish, transients remain eerily silent. They don't broadcast their position with clicks or chirps. They listen. They stalk. They drift through the water like phantoms, waiting for the right moment to strike. It's a strategy built for stealth, because their prey isn't passive. It hears, it evades, and it fights back. These orcas are after sea lions, porpoises, seals, even young whales, creatures with sharp senses and sharp teeth. The kind of prey that demands intelligence, coordination, and raw power. To support this hunting lifestyle, their bodies have followed suit. Transients tend to be slightly longer and more robust than residents. Their jaws are bulkier, adapted for gripping and tearing. Their teeth, flatter, more worn, tell the story of a lifetime spent crunching bone and thick hide, not soft, slick fish. Even their dorsal fins lean more sharply. Rather than sprawling extended families, transient orcas travel in smaller, tightly bonded units, often a mother and her offspring. These pods are agile and efficient, suited to the strategic coordination needed for high-stakes mammal hunting. If residents are community corps, transients are silent strike teams. What's emerging here isn't just variation, it's specialization. Transient whales, overall, are very quiet compared to the residents. When they are foraging, they're usually completely silent. And the deeper scientists looked, the more the question shifted from why are they so different to how long have they been this different? The answer, as it turns out, lies buried in their genes, and it's older than anyone expected. Asterisk, a genetic rift 300,000 years deep, asterisk. Sometimes the clearest truths are buried in code. And in the case of orcas, it was the double helix that finally laid bare what appearances could not. Genetic testing didn't just confirm that transients and residents were different, it revealed they were anciently different. The numbers don't lie. A divergence of approximately 300,000 years. That's longer than modern humans have walked the earth. Back then, continents looked mostly the same, but the creatures moving across and through them did not. And while our early ancestors were just beginning to make stone tools, these orcas had already split into two lineages, evolving apart across time, diet, geography, and behavior. It's important to understand what a separation like that really means. These aren't just orcas who grew up in different neighborhoods with different tastes in food. This is deep evolutionary isolation. Despite overlapping in territory, sometimes swimming in the same coastal waters, transients and residents have never interbred. Not once. That's not just unusual. It's nearly unheard of in marine mammals, who share so much ecological space. Researchers with the National Oceanic Atmospheric Administration have long been searching for this species, dubbed asterisk type D killer whale asterisk. Alicia's been looking for it too. In evolutionary biology, this kind of reproductive isolation is a key marker of speciation. If two groups live in the same environment but cannot, or will not, reproduce, something profound has occurred. It's no longer a case of cultural drift, it's genetic disconnection. And the differences don't stop at breeding behavior. Genomic data shows variations in immune systems, mitochondrial DNA, and neurological development. Even the orca's acoustic signatures are genetically ingrained. The way they listen, the way they interpret sound, it all maps back to their divergence. These are not orcas who could someday reunite. These are orcas who have become strangers. So now, with biology pointing in one direction and behavior in another, we find ourselves staring at a clear truth. We've been mislabeling an entire species for centuries. But how did such a glaring oversight last this long? That answer lies in how we see, or, more accurately, how we fail to see what's hiding in plain sight. Transients have been hiding in plain sight It's one of the most humbling realizations in all of science. Just because something is familiar doesn't mean we understand it. And when it comes to orcas, familiarity may have been our biggest blindfold. For decades, scientists had all the evidence right in front of them. Behavioral differences, acoustic distinctions, dietary rigidity, even clear social structures. Yet all of it was brushed aside as ecotypic variation minor adaptations within a species. It was easier to believe that orcas were incredibly flexible than to admit we might have been wrong about their very identity. After all, how could a new species be hiding in the most filmed, studied, and adored marine mammal on the planet? But therein lies the trap. The more an animal becomes an icon, a symbol of intelligence, playfulness, and raw power, the more we assume we already know it. And so, subtle signals go unnoticed. When an orca refuses to vocalize, we call it shyness. When it avoids others, we say it's an outlier. When its teeth wear differently, we chalk it up to diet, not speciation. We didn't lack the tools to spot the difference. We lacked the willingness to believe that such a difference could exist right under our noses. Compounding that was taxonomy's own rigidity. For centuries, species classification was built on morphology, the study of physical form. And by that metric, orcas are surprisingly uniform. But behavior, culture, and communication, these are the new frontiers. And they don't always leave fossilized proof. What finally tipped the scales was the consistency of the evidence. Across decades of data collection, a pattern emerged, too robust to ignore. These weren't merely alternative lifestyles within one species. They were two worlds coexisting in the same sea, speaking different languages, raising their young with different rules, and evolving along divergent tracks. Now that the veil is lifting, the full scope of the difference is coming into focus. And at the heart of it all is a way of life, a culture, unlike anything we ever imagined or truly understood. Which is where we go next, into the sharp, calculated, and astonishing world of the mammal hunters, the mammal killers. To understand the true nature of these newly distinguished orcas, you have to study how they hunt. Because in their world, every decision is a matter of life, death, and strategy. These aren't fish chasers echoing through reefs. These are precision mammal hunters. And their methods reveal just how far they've evolved from their fishing cousins. Transient orcas don't announce themselves. They navigate in total silence, avoiding echolocation entirely. While their cousins use sound as a navigational tool, transients treat it like a liability. The marine mammals they target, seals, porpoises, sea lions, even small whales, have evolved sharp auditory defenses. A single click could give away a hunt. So the transients rely on passive listening and stealth, gliding silently just beneath the surface until they're ready to strike. Their bodies have adapted to support this ruthless efficiency. Their jaws are larger and more muscular. Their teeth, noticeably blunted from the constant grinding of bone and cartilage. Compared to residents, their skulls are shaped to deliver more crushing power. These aren't opportunistic feeders. They're purpose-built predators. The prey they go after is fast, agile, and often dangerous, meaning a single mistake can lead to injury or death. These orcas don't just overpower their targets, they outwit them. They also hunt in small, tightly coordinated units, typically 3 to 7 individuals, often all related. This compact pod size makes communication easier and movements more synchronized. When attacking, they use strategies that feel almost choreographed. Some serve as decoys, drawing the prey into shallow water, while others circle and flank. Once the time is right, a single blow from a tail or a carefully positioned bite ends the chase. It's violent, yes, but it's also astonishingly intelligent. There's no panic in these hunts, no chaos, just calculation. It's not enough to be fast or strong. Transients succeed because they study their prey, plan ahead, and adapt in real time. And the more we observe them, the more it becomes clear that we're witnessing not just evolved behavior, but something more nuanced, something cultural, which leads us directly into their opposites, the coastal orcas who hunt nothing with teeth, but instead navigate by sound, social ties, and salmon. Asterisk, asterisk, the salmon singers, asterisk, asterisk, while the transient orcas operate like elite hunters on silent missions. Their close relatives, the resident orcas, live in a world of noise, tradition, and cooperative family life. Where transients are secretive and sparse, residents are social and vocal, often traveling in large extended pods that behave more like multi-generational communities than hunting teams. Resident orcas eat fish, almost exclusively salmon, and they use their voices to find it through a complex system of sonar clicks and whistles. They bounce sand through the water, creating audio maps of their surroundings. To the untrained ear, it might sound like a chaotic chorus, but to scientists, these are deliberate, repeated acoustic patterns, a kind of language. Each pod has its own dialect, passed down from mothers to calves, encoded in memory like family recipes. Their entire lives revolve around this food source. They don't hunt seals. They don't chase dolphins. Even when fish populations plummet, resident orcas will not deviate. Unlike opportunistic predators, they remain loyal to their cultural norms, which in times of scarcity becomes a costly decision. But that stubbornness isn't random. It's inherited behavior, reinforced over thousands of years. Socially, their structure is the polar opposite of the transients. They gather in pods of 10 to 20, often more, anchored by matriarchs who hold the knowledge of where to find food throughout the year. These elder females lead not with brute strength, but with experience. When a pod loses its matriarch, younger members often struggle to survive. It's not because they can't swim. It's because they no longer know where to go. And while their bodies might appear similar to transients at first glance, there are subtle but consistent differences. Their teeth are sharper and less worm, suited to gripping slippery fish. Their skulls are sleeker, their dorsal fins rounder. Every inch of them is tuned to their chosen way of life, a way that depends not on muscle, but on memory. But that memory isn't just individual, it's cultural. And now, scientists are starting to realize that it's not just shaping how these orcas live, it's influencing what they become. Culture that builds a species. For decades, the concept of animal culture was treated as something sentimental, the kind of soft science that couldn't be measured or proven. Biologists acknowledged that animals learn from one another, but few were prepared to say that such behavior could influence evolution itself. That view is beginning to collapse. And nowhere is that collapse more visible than in the story of the orcas. What separates the transients from the residents isn't just diet or pod size or range. It's a complete and consistent transfer of behavior from one generation to the next. Young transient orcas don't just instinctively know how to ambush seals. They learn it through months or even years of watching their mothers and aunts. Similarly, young resident orcas don't just stumble into echolocation. They're taught the sounds, the techniques, the migratory rhythms that allow them to find salmon when the ocean seems empty. These are not isolated tricks. They are systems of knowledge passed down over time, reinforced by practice and repetition. When a calf doesn't receive that education, when its teachers die or are separated, its chances of survival plummet. This kind of dependency on social learning has long been considered a hallmark of human evolution. But orcas are rewriting that rulebook, and over time, these learned behaviors don't just shape minds, they shape bodies. The transient's tooth wear isn't just environmental, it's hereditary. The same goes for jaw shape, body mass, swimming endurance. Evolution is responding not just to climate or food availability, but to behavioral tradition. Culture, in other words, is becoming a biological force. This idea that culture can push two groups of the same species so far apart that they eventually become different species was once controversial. Now, in the orca world, it's becoming undeniable. The weight of this realization is pressing down on the scientific community. Because if behavior can drive biology, then the entire system of species classification may need to change. When science hits its limit, science is, at its core, a system for understanding the world. But like any system, it comes with boundaries, definitions, rules, categories that help make sense of complexity. And when it comes to defining what a species is, those rules have long been rooted in physical traits, body size, anatomy, reproductive compatibility. But the Orca challenge has exposed a glaring flaw in that framework. What do you do when two animals look alike, live side by side, but are clearly not the same? That's the dilemma facing taxonomists in 2024. The evidence supporting the classification of transient orcas as a separate species has reached critical mass. The genetic divergence, the non-overlapping reproduction, the behavior, the vocal silence, it's all there. But what's missing is a formal decision. Why? Because our classification systems weren't built to handle culture. We're now staring down the limits of 19th century science in a 21st century world. And for marine biologists, that means having to update not just the species list, but the philosophy behind it. If culture is now a speciation mechanism, then our models must evolve, because failing to account for that doesn't just blur the boundaries of biology, it can have real-world consequences. Species classification isn't just a textbook exercise. It determines which animals are protected under international law. It affects conservation funding, policy decisions, marine zoning, and even shipping regulations. If transients are finally recognized as their own species, it could reshape how we protect orca populations around the world, and how we evaluate other animals whose identities may also be culturally defined. This isn't just about orcas anymore. It's about the need for science to keep pace with the life it seeks to understand. And if we're willing to adjust our lens, we may start seeing that this isn't the only species we've misjudged, just the one that's finally forcing us to admit it. Species rising. Another disappearing **. Nowhere is the divide between these orcas more visible, or more tragic, than in what's happening today in the wild. While the newly proposed species of transients appears to be thriving, their fish-eating cousins, the residents, are quietly unraveling. Let's start with the transients. Their numbers have been climbing steadily over the past few decades, particularly in the North Pacific. From around 120 individuals in the early 1990s, one key population grew to over 280 by 2010. That's more than double, and it's no coincidence. Their diet consists of marine mammals like seals and sea lions, many of which have rebounded under environmental protections. Transients have the upper hand. Their prey is abundant, their pods are efficient, and their cultural knowledge is intact. In short, their evolutionary strategy is working. Now contrast that with the southern resident orcas, a group whose name sounds peaceful, but whose reality is anything but. This population is in crisis. Their preferred prey, Chinook salmon, is vanishing due to overfishing, habitat destruction, and climate-driven changes in ocean conditions. Despite having thousands of miles of ocean at their disposal, residents refuse to switch prey, even when starving. And that's not a flaw. It's a feature of their culture. These orcas are loyal to their traditions. But in a changing world, that loyalty is starting to cost lives, and the damage runs deeper than hunger. Resident pods are socially structured around elder females, matriarchs who remember the best feeding grounds, seasonal migration routes, and call patterns. When these leaders die, the loss is more than personal. It's a collapse of generational memory. Without that knowledge, younger orcas can't simply figure it out. They don't know where to go or how to hunt. Their survival isn't just tied to biology, it's tied to wisdom. This makes the misclassification all the more devastating. For decades, conservation plans lumped all orcas together, treating them as one adaptable species with uniform needs. But they're not. The transients are rising. The residents are vanishing. And the failure to recognize their differences soon enough might have sealed the fate of one. This isn't just a mistake of labels. It's a warning, one that echoes far beyond the dorsal fin. Asterisk, asterisk, are we missing any more asterisk, asterisk by now? It's clear the orca revelation is bigger than taxonomy. It's bigger than conservation. It's a mirror, reflecting back just how little we understand about the complexity of life, even in places we've studied for generations. Because if we can mistake two separate species of orca for one, despite decades of close observation, you have to ask, what else have we overlooked? This isn't about remote rainforests or deep ocean trenches. The orca story unfolded in coastal waters, among animals we've tagged, tracked, filmed, and idolized, and still we missed it. That should unsettle us in the best way. It opens the door to a larger truth. Our systems for classifying life are still playing catch-up with life itself. The natural world doesn't always fit neatly into the boxes we've built. It evolves faster than bureaucracy, and it expresses itself in ways that defy simple categories. Culture, communication, social learning. These things don't fossilize. They don't show up in museum drawers or decades-old field guides, but they shape species just the same. And it's not just orcas. Other intelligent, socially complex animals, elephants, dolphins, wolves, parrots, even crows, all show signs of culture-driven evolution, dialects, tool use, migration traditions, teaching behaviors. We're starting to see the pattern. But how many of these species have internal branches, distinct lineages hiding behind shared faces that we haven't recognized? The orca isn't the only one. It's just the most glaring example, the one that's forcing the scientific community to admit we've underestimated the role of behavior in shaping biodiversity. Asterisk, asterisk, so what comes next, asterisk, asterisk, maybe a redefinition of what species means. Maybe a more holistic approach to ecology, one that includes language, lineage, and learned behavior alongside genes and bones. Maybe we start listening more closely to the animals that already seem to be speaking. Whatever the case, one thing is clear. The orca story didn't close a chapter. It opened 1,000 new questions. Asterisk, asterisk, the final reckoning, asterisk, asterisk. This discovery didn't come from an expedition into the unknown. It didn't emerge from some undiscovered corner of the map. It came from the familiar, for a creature we thought we had already figured out. That's what makes it so powerful. The idea that orcas, these charismatic, intelligent, almost mythic beings, could contain multiple species within their name isn't just fascinating. It's transformative, because it tells us that the greatest discoveries may not be hiding at the edges of our world, but at the center of our assumptions. We now know that transient orcas are likely a new species, shaped by centuries of silent hunts, cultural instruction, and genetic independence. Their differences aren't cosmetic, they are systemic, baked into their DNA, encoded in their behavior. reinforced by every silent swim and calculated strike. And this realization didn't just update a textbook. It reframed the way we look at intelligence, identity, and evolution itself. The orcas didn't change. We did, or rather, we finally started seeing what was already there. This isn't just a story about taxonomy. It's about perception. It's about what happens when science becomes humble enough to question what it thought was certain. And it's a call to action, to look again, listen longer, and assume less. Because the moment we truly saw the transient orcas for what they are, everything changed. Not just for them, but for our understanding of the living world. And perhaps the most exciting and terrifying part of all this is the possibility that discoveries just as big are still waiting, quietly, patiently, in the places we thought we knew best.